Good morning everyone. I am Chirag Kundia here to discussing about mechanics of solid. Mechanics of solid is the study of mechanics of solid, and I will discuss about mechanics of solid and also fundamental of mechanics of solid. As we go in details about mechanics of solid, we should know about mechanics. What is mechanics? Where it stands for. As mechanics is divided into different parts. One is mechanics, another is mechanics of solid. Mechanics is divided into three different categories. First one, we say that engineering mechanics. Engineering mechanics. Second one is mechanics of solid, strength of material, mechanics of material, and solid mechanics. Third, but not least, is mechanics of fluid. Our engineering mechanics deals with now mechanics. First about mechanics. Okay. Mechanics. Mechanics is the study of. Mechanics is the branch of science where it deals about the study of external forces, internal forces, and their effect on the body, on structure, solid or machine, whatever it is. Study of that forces and internal effect is called as mechanics. Now our mechanics is, as I told, divided into three different categories. Engineering mechanics is the branch. Engineering mechanics, here we discuss about the study of only external forces or the study of the rigid body. Study of the rigid body. Rigid body. Study of the rigid body. Here, what interpreted study of the rigid body? Here, deformation of the body or change in the shape is neglected. Change in the shape is or deformation is zero or negligible. Okay. Now our engineering mechanics is divided into different categories. Static and dynamic. Static is that where variation of load variation does not vary with respect to time. It means load is constant with respect to time. While in case of dynamic, load is varying with respect to time. It means not equal to constant. Okay, with respect to time. Now dynamic is further subdivided into different categories. Kinematic and kinetic. Kinematic is that where only we discuss about the motion only, and in case of kinetics we discuss about motion and the force causing motion. Now, but on the other hand, our mechanics of solid, here one thing, mechanics is the internal and external forces. We discuss about internal and external forces. Now our external forces is external and internal. External we say that load, and internal we say that the depends on the property of the material. Then we say that stress, which I have discussed in detail later. So in mechanics of solid, we discuss about, here we are discussing about external load, only external. In case of engineering mechanics, here we discuss about both load and stress. That is external and internal forces both we consider here. And mechanics of solid is so if load stress is considered, there are internal properties. So here we consider both external and internal forces and deformable body. Here we consider the study of the deformable body. Study of deformable body. Clear? Now let's talk about mechanics of fluid. Mechanics of fluid is also divided into different categories. Mechanics of compressible fluid and another one is the mechanics of incompressible. What it will be that compressible fluid is that density is not constant, density is varied with the variation of pressure, while in case of incompressible fluid, density is varying with respect to pressure, while in case of incompressible fluid, density will not vary with respect to pressure. It means here density is constant. That is not our topic, that's a part of fluid mechanics, and this one is part of basic engineering mechanics that we are drop out here, and we will discuss only about this topic. Mechanics and of solid also. As we know, the mechanics of solid, or sometimes also strength of material, deals with the relation between the external forces and their internal effect on body. And in actual design, engineer tries to consider both dimension and properties of material, so that material cannot be neither break nor deform excessively. The purpose of studying SOM is to ensure that the structure of the body is able to perform their work in the different environment that we discuss about in mechanics of solid. Now, our forces. Let's know about forces. Forces is of two types. That force is a basic definition that you know is basic. Surface force and body force. Let us consider a diagram that is, suppose this is a bar of any length L, and here any acting load P is acting, and that P is acting on the cross-sectional area A. So in this cross-sectional area considered A, that we call as surface area. The force which acting on the surface of the body or distributed over the surface of the body, that we consider it as a surface force. So P distributed over the surface. Distributed over surface. So P is an example, P is the surface force. While on the other hand, body forces is distributed over the volume of the body. Distributed over volume of the body. Now, suppose this is a body, and its weight density is something low. G is its specific gravity, G is its gravitational acceleration, and mass rho G is its weight. Okay, rho G into AL. Okay, this is a weight. This is a body. This is acting over whole of the body and is concentrated about a certain point. Means body force is concentrated about a particular point that we call as center of gravity. So weight of body is considered as body forces. Okay. Now let's talk about load. 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 What is the load? Load is an external force, which is external force or couple or movement which is acting on a body. What is this? External force, couple, movement, etc. acting on a body. Now load is also classified into three different categories. One is according to, with respect to the time. Second one, with respect to the direction, or we say that with respect to the cross-sectional area. Cross-sectional area. Third one is the with respect to the variation of load. Variation of load. Now, with respect to time, it is divided into two different categories. One is static load, and another one is dynamic load. Static load, we say that where the intensity of load is not varying with respect to time. Suppose that in this one, suppose this is the load, time, we are plotting a diagram graph between time and load. Here, if P is constant with respect to time, that we call as static load. Okay? Now, static load. Now, our static load is also subdivided into two different categories. Dead load and gradually applied load. Gradually applied load. What happens? Static dead load is considered as whatever the load is acting, it's always same at any particular time, whatever 100 2 years, 1 month, 1 minute, 2 minutes. After any time, it always acting this point of load value P. By means of gradually applied load, if we plotting diagram, suppose that this is P and this is P, then its intensity is varying with respect to time, like as what? Like as this. Here P is, suppose here maximum load is P max. As I told, what is static load? Here intensity is not varying time, but here is load is varying with respect to time. But however it is considering gradually applied load. Why it is considering gradually applied load? Because if we consider about the slope of this P and T diagram, then we can find that this variation of load P, del P, and variation of del T, change in pressure with respect to that change in del T time is very less. Means change of magnitude of del P is very less as compared to del P. So it is considering as a static load. On the other hand, our dynamic load is also subdivided into different categories. One is our impact load, and another one is fatigue load. Impact load is also called as sudden load or shock load. If we draw here our diagram of impact load with respect to time, then we find that intensity of varying pressure. Here, suppose if we consider a small element here, then what we find that this is the change in time, and this is our change in load, that del P, and this is del P. Here, slope is very high. Means in a small fraction of time, our intensity of load changes from 0 to maximum value Pmax, and here its slope is very low, so it takes a certain time, definite time to reach its maximum value Pmax. So it's a sudden or impact load. This is a case of sudden or impact load. So now this one is also, we can think that in a case of hammering action that we read in water hammer, or we can say that in a gearing action. Such case, what happens is per gear that a tooth comes in contact and sudden engagement and sudden load increases, so axial thrust will increase. There are the topic of theory of machines, so I will not discuss here. So let's discuss about fatigue load. Fatigue. Okay. What is fatigue load? Fatigue load is that kind of load where intensity of load is varying, means magnitude is varying with respect to time, or direction is also varying. Direction also. And sometimes we say that both the things are varying, or both are varying. Let us, both are varying. Let us consider an example. Suppose this is an any part. Here P load is acting. This one is simply is a P load is acting. This is a simple or a static load. If another case consider, this is diagram A. Consider another diagram. This is load P. Here load P is varying from plus P to minus P. Okay. Plus P to minus P. So what happens? One time its direction is positive, that means tensile, or another side its direction is reverse, this is compressive. So it is fluctuating from compressive to tensile, its direction is changing, so we can say that it is a completely reverse stress. Completely reverse load. Reverse load. That is that B. Another diagram, suppose if here plus P2 plus 2P. Here only magnitude is varying. Only magnitude is varying. Here. So magnitude is varying while direction is remains constant. It is called a fluctuating stress. Fluctuating load. Another one is case where here our only direction is changing. Here only our load is magnitude is changing. Another case, suppose both are changing. Minus P2 plus 2P. Okay, that we call as alternating fatigue load. Alternating fatigue load. Fatigue load. Both the things are varying. So these are the according to the with respect to the time. Now, if I discuss about this one is from fatigue load. It's dynamic load. Now we will discuss about with respect to the direction. No, leave it. This is not direction. First discuss about with respect to variation of load. With respect to variation of load. With respect to the variation of load, it is further divided into two different categories. One is concentrated load. Another one is distributed load. What is concentrated load? Concentrated load is acting at a certain point, at a means a very small area. That we call as concentrated point load and the concentrated movement. While distributed load is divided into different other categories. Uniformly distributed load, uniformly varying load, and uniformly distributed movement. These are the according to the variation of load. Now, if we consider about with respect to direction, with respect to the direction of load, it is divided into two different categories. Normal load of shear load. Normal load is divided into another direction. One is axial load, another one is eccentric load. These both are further also divided into another two different parts that we call tensile or compressive. And shear load is further subdivided into two different directions, such as transverse shear load and eccentric transverse shear load. Eccentric transverse shear load. Now, let's discuss about axial load. Okay, axial load. What happens in any cross section? In any section there is two things. One is longitudinal direction, another is longitudinal axis, another is transverse axis. Normal load is acting along the longitudinal axis. Suppose this is any bar. If any load, this is longitudinal axis, is acting P. This is normal to the axis and normal to the cross section, acting along the longitudinal axis and perpendicular to the cross section. So we consider as normal, consider as axial load. Another one is eccentric load. Here, parallel to the longitude, parallel to the eccentric load, parallel to the cross section, while eccentric normal load, perpendicular to the normal cross section, while parallel to the longitudinal axis. Another case, if we consider like a tensile and compressive, if we go from point to away, that we can tensile, if towards any point, that means a compressive load. Say transverse load, tangential to the load. Transverse shear load is always acting parallel to the surface, tangential to any surface. Suppose this is any lifting section. If load is P is acting here, then P is acting, our load is acting parallel to the cross-sectional surface, parallel to the cross-section, or perpendicular to the longitudinal axis. And similarly, eccentric parallel to the longitudinal axis, but away from the longitudinal axis. Now, let's discuss about stress. What's the time? Okay. Stress. Due to shortage of time, let's finish in short. Suppose this is any prismatic bar. If any stress P is acting on P, any load P is acting on that bar, AB of definite length L, then what happens if load is increases up to certain time? Then if we consider a particular cross section, that is suppose this M section and M section, then if we see, then this is P, this is M and P, then there is somewhat internal stress is generated for maintaining the equilibrium position. Let's say that sigma, this interresting force. Stress is a kind of whenever an external load is applied, then body tries to resist that external force, that we call as stress. That is sigma, that is uniformly distributed over the area A. So what is sigma? Uniformly distributed of the load over any cross-sectional area per unit area. That is sigma is equal to P by A. Its unit is like as if it P in meter and A in mm, or meter, then what is Newton per meter square or Newton per mm square or Newton per meter square, we can see that Pascal. Now, 5 minutes remaining. Stress. This is stress is a we got that sigma is an internal force. If this induced stress is what is strength? What is strength? Strength is that tries to resist external load up to a certain time. After a certain limit, it either breaks, deforms, or it loses its elasticity. Means plastic deformation starts. The limit up to that point, plastic deformation starts, or fracture, that we call as strength. If induced, suppose if I am representing strength by SUT or S by T, SUT ultimate tensile strength, S by T yield tensile strength. If our induced stress is lesser than ultimate tensile strength, then material remains elastic. Material remains elastic, and it remains elastic, and no permanent deformation. No permanent deformation. While if sigma induced is sigma by T, sorry, this is sigma by T. If sigma induced is less than SUT, then permanent deformation exists. Permanent deformation exists. But fracture will not occur. Fracture will not occur. If this sigma induced is greater than SUT or equal to SUT, then fracture will occur. That we call as strength, ultimate strength. So this is the Newton per mm square. Also, now let's discuss another topic. As I told that every engineer try to build any structure that will not deform or not get their rigidity and strength on the application of load. Okay, and suppose we saw that any bridges, any structure, railway bridges, any trusses, that should not lose their strength after the passage of time, because after the passage of time there is some stresses will induce. That stress should be resisted by that kind of structure. So everywhere we consider that strength for so that its properties should not be losses with the passage of time. So whatever we are building, we consider that its properties should not losses. Another things, in point of gate, if we go in that analyze the past paper, then we consider that SOM is not an individual topic. It covers mechanics, design, and so strength of material also. If we conclude both this step, we can get that 8% to 10% SOM will come in gate. If 5 mechanics comes also 4 to 5%, and 6 to 10% is also our design will come, engineering design. So it's around 20 to 25%. So in the point of view gate, the strength of material is a basic part to crack and gate exam to score a higher marks. It creates a dividing line in between you and others who are not focusing on design part. Now, if I discuss about gate, why it is important? Gate. After passing our engineering, we will go for a job definitely, or higher research, or any other organization to teach. Then, what is the scope of this gate? We have to, in the present time, gate is a benchmark for that thing, for everything, PSU or. I was around gate. Okay. Why gate is important in the present time? You know that gate is a today's time benchmark for everyone. For if you are looking for PSUs, going for industries, or if you are looking for going for research, higher study, then gate is a necessary part to crack the exam and going for further study or further going for a job or join any organization for anything. Like that PSU, industries, PSU and higher study, both are including through gate. In case of higher studies, suppose if you are looking for higher study in IITs, NIT, or any reputed college, government college, then you have to crack You have to crack a GATE exam and score a higher marks to achieve to take admission in IITs and NIT or separate college. If you are looking for PSUs or industry, you know that almost all PSU around 30 to 50 PSU are including through GATE exam. Almost all, not almost all, recruiting through single one exam GATE. If you what happens in the past few years ago that different PSU are recruiting a different exam and organizing different exam, and you have to prepare different strategic planning for crack that exam. But here on this through single one exam GATE, you are able to find your platform for your career in different 30 to 50 PSUs. Whatever it is, whatever you apply, 30 to 50 PSUs different acts and by a single one exam. So GATE is the most valuable and most I think most recognizable way to build your career. And either if you are doing a PhD or higher studies, it's good thing for GATE. You have to focus only on a particular strategic planning, and there are a lot of strategy, lot of methods are available to how to crack that GATE exam, and you can build your career in better way by through single one exam that we call as GATE. So thank you for your kindness and thank you for your patience. God bless you.